In this problem, we have an Atwood machine which consists of a pulley that we will assume has no mass or friction, that connects two different masses, one being 23 kilograms and the other being 41 kilograms. We want to find the acceleration of the two masses due to the acceleration due to gravity. We also want to find the tension on the rope holding the two masses together. To start off, we need to get these two masses into forces from gravity. To do so, we can take these masses and multiply times the acceleration due to gravity, which is 9.81 meters per second per second. Thinking about these two forces, they are counteracting each other, so we can subtract one force from the other force to get the net force that is causing the boxes to accelerate. Doing so, we are left with 176.58 newtons of force, net. Now to get the acceleration, we must divide the net force by the total mass of the system, or in other words, 23 kilograms plus 41 kilograms. Doing so, we are left with an acceleration of the system of 2.759 meters per second per second. I have listed an arrow on the pulley system which represents the direction of the motion. The heavier mass lowers and the lighter mass raises up. Looking at the purple 23 kilogram mass, we have two accelerations acting opposite of one another, one being the acceleration due to gravity and the other the acceleration of the system. So we can take the force due to gravity and add the force due to motion to get the tension force acting on the table. Doing so, we are left with a tension force of 289.09 newtons. Your answer might vary slightly due to the rounding at different stages. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching.